Remember that for a histogram, it's the area of the bar that represents the frequency. So when we're told that there are 12 tomato plants between 75 and 85, so here's 75 and here's 85, I know that the area of this bar is 12. The width of the bar is 10. Between 75 and 85, the width is 10. So that must mean that the height of the bar here is 1.2, because 10 times 1.2 gives me the area of 12. Now I've got some information on my y-axis, so I can use that to fill in the other numbers here. Now, let's see about this scale. I've got 10 little squares up to there, 20 up to there, so there's 24 little squares here that represents 1.2. So 1.2 divided by 24 is 0.05. So each little square here is 0.05. So 10 little squares will be 0.5. So this will be 1. This would be 1.5. This will be 2. This would be 2.5. So I've got my scale there. Right, so let's carry on reading. One of the tomato plants is selected at random. We need to find an estimate for the probability that this tomato plant has a height greater than 82.5 centimetres. So 82.5 centimetres is here. So these are the tomato plants that are above 82.5 centimetres, and we need to work out the probability of the plant being chosen being above that, which is going to be, so the number above 82.5 divided by the total. That'll give us an estimate for the probability. Right, so for the total, let's work out the area of each of these bars. So for the first bar, the width is 5. The height here, remember that each little square is 0.05, so 2 squares will be 0.1. So that's 0.6 there. 5 times 0.6 is 3. The next bar is 10 wide, and its height here, well, this would be 0.7, that's going to be 0.8. 10 times 0.8 is 8. The next bar is 5 wide, its height is 1, so 5 times 1 is 5. The next bar we already know about, was 12. And the final bar here, the width is 5. The height here is going to be 0.4. So 5 times 0.4 is 2. So in total, there is 3 plus 8 plus 5 plus 12 plus 2. Which is 30. So there are 30 tomato plants in total. How many of them are above 82.5? Well, we know that there's the 2 in here, that's easy. question is, how many are there in this little bar here, this little blue bar? Different ways of doing this. I could do just a quarter of 12. Hopefully you can see why I would do a quarter there, because this is 1/4 of the whole thing. Or alternatively, using the same method as I did before, what's the area of that blue bar there? The width of the blue bar is 2.5, the difference between 82.5 and 85. The height of that blue bar is the 1.2. So 2.5 times 1.2 is 3, which is the same thing as the quarter of 12. So either method, we've found that there are 5 plants with a height above 82.5 centimetres. So the probability of me choosing a plant with a height greater than 82.5 centimetres is 5 out of 30. Or 1/6 if you wanted to simplify it, but there's no need to do that here.